You know what time it is. It's another day to get better. Today, on Test Prep Friday, our subject of focus is Algebra I. We'll be looking at the standard n.Rn.3, which states, explain why the sum or product of two rational numbers are rational, that the sum of a rational number and an irrational number is irrational, and that the product of a non-zero rational number and an irrational number is irrational. We'll also look at a couple domain problems relating to real number system. Let's break this down. If you identify a rational number and utilize any operation, whether it's addition, subtraction, multiplication, or division, with another rational number, the result will always be rational. If you identify a rational number with any operation, once again, with an irrational number, it will always result in an irrational number. This is where it gets a little tricky. If you recognize or identify an irrational number and utilize any operation, whether it's addition, subtraction, multiplication, or division, with another irrational number, the result is sometimes rational or irrational. Now let's apply these concepts to some test style type questions. Let's look at number 23. A student claims that the product of a non-zero rational number and an irrational number is always irrational. Is the student's claim correct, and why? So what are we dealing with right here? A rational number and an irrational number. Our rules have identified that if you multiply, divide, add, or subtract a rational and an irrational number, it will always be irrational. Through process of elimination, we eliminate answer choice A and answer choice B, which state that the students aren't correct. Now let's analyze C and D. C states that the student is correct because 1.2 pi times 6 pi is 7.2 pi squared. And 7.2 pi squared is an irrational number. But let's look back. We were supposed to be multiplying a rational number and an irrational number. 1.2 pi is irrational, and 6 pi is also irrational. So we'll eliminate C, leaving the correct answer to be D. The student is correct because the square root of 25, which simplifies to be 5 because 25 is a perfect square, which is a rational number, multiplied by pi, which is the famous irrational number, equals 5 pi. And it is true that 5 pi is an irrational number. Let's continue. Number 23. Let A and B be rational numbers, and let C be an irrational number. Select the correct item that makes each statement true. The sum A plus B is. All right, let's look back. Okay, both A and B are rational, and we're adding two rationals. Our rules told us that it will always be rational. The product A times B is always rational, never rational, or sometimes rational. Once again, A and B are both rational numbers. Product means to multiply, so we're multiplying two rationals. Any operation with two rationals is always rational. The correct answer is always rational. The square of C is, now let's look back, C is an irrational number. If we recall, it's where it gets a little tricky. If you add, subtract, multiply, or divide irrational numbers, it's sometimes rational and sometimes irrational. So let's analyze the answer choices. If C is an irrational number and you square it, you multiply it by itself. We eliminate always rational. We eliminate never rational. And it holds true that this is sometimes rational. And the next question. The sum of two rational numbers is rational. Which expression supports the statement above? The definition of rational numbers tells us that they terminate or repeat and can be written as a fraction. Our irrational numbers are non-terminating and non-repeating and can't be written as a fraction. Let's analyze these answer choices, all right? 60. Unlike the 25 in the previous problem that we looked at, 60 is not a perfect square. So the square root of 60 is an irrational number. We're supposed to be adding two rationals. So through process of elimination, we eliminate A. Let's look at B. 45 over 11. That is a fraction, so it holds true to be a rational number. We're adding the square root of 15. Is 15 a perfect square? No, it isn't. So the square root of 15 is actually an irrational number. Doesn't meet the criteria. We eliminate this one. Next, square root of 8 plus square root of 5. 8 and 5 are non-perfect squares. So we're adding here an irrational and an irrational. Once again, we're looking for two rational numbers. We eliminate this one, which leaves the correct answer, D. We have two fractions, 27 over 59 and 30 over 24, both rational numbers, which will result in a rational number. Let's continue. Tickets for the school basketball game cost $4 each. Sadie plans to make a table relating the number of people, X, to the money made from ticket sales, Y. What is the most appropriate domain for Sadie's table? Domain is represented by the X values in a function. The X in the context of this problem represents a number of people. Domain also represents the input. So in the context of this problem, we'll be inputting a number of people attending the basketball game for $4 each. Let's analyze the answer choices to determine the most appropriate domain. All integers. All integers. What are our integers? Integers are our negative and positive whole numbers. Negative and positive whole numbers. Can the number of people ever be negative? No. We'll eliminate A. All rational numbers. All, there's that term again, all rational numbers, which includes negative and positive numbers again. We'll eliminate B. All real numbers. All numbers are real, even pi. Will we ever input pi number of people? All real numbers also includes negative numbers as well. The number of people will never be negative. We'll eliminate C, which leaves the correct answer, D, all whole numbers. All whole numbers won't include negatives. Let's continue. A basketball game sells admission tickets for $5 on Wednesday nights. At capacity, the theater holds 500 customers. The function B of n equals to 5n represents the amount of money the theater takes in on Wednesday nights, where n is the number of customers. What is the domain of B of n in this context? B of n is function notation, and it identifies that n is our input variable. N represents the elements of the domain. What does n represent in the context of this problem? N represents the number of customers. Well, let's analyze our answer choices to determine the most reasonable domain. What are our whole numbers? Whole numbers are our counting numbers and 0. 0, 1, 2, 3, 4, 5, so on and so forth. We'll consider that one. B, all non-negative rational numbers. Rational numbers terminate or repeat and can be written as a fraction. Would there ever be a fractional number of customers? No. All non-negative integers that are multiples of 5. What are the multiples of 5? 5, 10, 15, 20, 25, so on and so forth. N represents the number of customers. The number of customers that attend the game don't have to be in multiples of 5. We eliminate C. All non-negative integers less than or equal to 500. We'll consider D as well. But there's a key bit of information in the problem. The author tells us that the theater can only hold 500 customers. That's what we call a restriction on the domain. The domain cannot exceed 500. In this case, 500 customers. With that information being taken into account, we'll eliminate A. All whole numbers continues on into infinity. With the restriction on the domain, the number of customers will be less than or equal to 500. Remember, every day is another day to get better.